Now that I've given you a high-level overview of what a condition variable is, let's talk about the guarded suspension pattern, which is very famous and appears as documented in a couple different places. So we typically use condition variables to implement the guarded suspension pattern. This is a pattern that's documented several places, one of which is the POSA 4 book, of which I'm a co-author. And this pattern requires both a lock to be acquired and a precondition to be satisfied before an operation can be executed. So just as an example here, let's say we want to have two client threads, client 1 thread, client 2 thread. They're trying to access some thread-safe message queue, and the first thread calls get message. Let's assume the queue is empty. We come in here, we acquire the lock, and while the queue is empty, we're going to wait on the not empty condition, and that'll basically suspend us until the queue is no longer empty. We are then able to get the message and then return it and release the lock on the way out. Down here, client thread 2 is going to try to put something in the queue, and so it acquires the lock. Of course, if someone already holds the lock, it has to wait. It stores something in the queue, and then it goes ahead and notifies that the queue is no longer empty and releases the lock. And we'll see there's all kinds of nuances to this, but that's the basic idea. So we take turns waiting and signaling each other when conditions arise that satisfy the conditions that someone else is waiting for. This pattern can be applied to operations that can only run when a given condition is satisfied. So we want to be able to run some operation, but only when a condition is actually satisfied. So the way it's going to work is we're going to have to acquire a lock, first thing you do, and that implies that a condition variable is always associated with a lock. So a lock and a condition variable always go hand in hand. And we'll talk more about how that works in Java, where you use a particular factory method to make that association. So once the lock is held, we then check to see if the condition is satisfied. If the condition is not satisfied, we're going to go ahead and we're going to have to wait. So you can't make any progress while the condition is not satisfied. And we'll see more about that in a second. Now, one of the things that you need to notice here is that when you're awakened after you wait, you have to recheck if the condition is satisfied, because just because the condition variable was signaled doesn't necessarily mean that the condition you're waiting on is satisfied. And that has to do with the fundamental non-determinism of concurrency. So we'll talk about that more momentarily. It's a little subtle. So again, here's kind of how it works. You have to acquire the lock. With the lock held, you check the condition. And that condition can involve shared state, which is why you need to have the lock held. The conditions that you're checking for can be arbitrarily complicated. They can be a simple check of some Boolean flag. It could be some series of method calls. It could be a bunch of checks of mutable shared state, whatever. That's one of the things that makes condition variables so powerful, is the fact that the conditions can be arbitrarily complicated. Unlike semaphores, where you're just incrementing and decrementing a count by 1. So you can have different ways of checking the condition. Any state that's shared between the threads has got to be protected by this lock. So the lock is going to be used to ensure that only one thread at a time can actually check to see if the condition is true or condition is satisfied. If the condition is not satisfied, we await, and what that does is that atomically puts the thread to sleep and releases the lock. Very important to understand. The releasing of the lock and the putting to sleep of the calling thread have to happen atomically. There can't be any erase conditions or windows in there. And one of the consequences of this is when you get reawakened, the condition variable will first reacquire the lock, and then when you loop back around again, it'll be held. Now, how do you get awakened? If another thread comes along and signals the condition saying things may now be maybe more desirable for another thread that's waiting, then that will go ahead and wake up the condition that's asleep. And then with the lock held, it'll recheck the condition to see if it's satisfied. And again, it doesn't have to be a method call. It could be some arbitrary expression involving shared state. So that's basically the protocol here. Waiting on a condition variable and waiting on a condition variable atomically releases the lock and suspends everything. So there's no There's no window in here. These two things happen simultaneously. So the lock is released when the thread goes to sleep. So that's really important too. And the reason for that is if we went to sleep holding the lock, nobody could ever get in there and acquire the lock to check to see if the condition has been satisfied. The thread is suspended until it's signaled by someone else. So it'll basically sit there asleep, and then when someone signals it, then that causes the lock to be reacquired, and we go back and check again to see if the condition has been satisfied. It may turn out, because of the non-determinism of concurrency, that even though someone woke us up, the condition is actually not satisfied. So we go back to sleep again and wait yet again. So this will go on until we finally get the condition to be satisfied. Yes, Nandi. Let's see if I understand your question. So yes, so the way to look at this is the condition that is checked here, which again would most likely be, or almost invariably, accessing some kind of shared mutable state, something that could be changing, like a count, or whether the queue is empty or full, or something like that. That has to be something that any other threads that are trying to check that data will also lock the same lock. So this lock is really used to protect the check of the condition, to make sure that it's not going to be subject to race conditions if things are accessed and modified simultaneously by multiple threads. So we use the lock to make sure only one thing at a time gets the chance to check that shared state. Yeah, that's a great question. It's very, very subtle. We'll look at this from a couple different points of view as we go on. Only after you finally got the lock and the condition is satisfied can you do the operation processing. And notice, by the way, that the lock is held here. We check to see if the condition is satisfied. If it is satisfied, we skip over the await and we go and do the operation processing, and that will be done with the lock held, because that will most likely update the shared state. And then something that I don't show here is that we'll unlock the lock on the way out so that someone else can go in there. So the lock gets unlocked a couple of different ways. It gets unlocked when a wait is called, and it also gets unlocked when we fall off the end of this piece of code, which I'm not showing at the moment, but we'll see that shortly. And it should come as no surprise to anybody that you want to use the lock and unlock in a try finally block so that you make sure the lock always gets released. Okay, so that's a quick overview of the concept of guarded suspension. And guarded suspension is really the abstraction that condition variables are designed to fulfill or designed to implement.